discussions about logic gates, we are going to start from the inverter. Inverter is the simplest gate which we are going to discuss. And why is simple? Because it has just one input and one output. If it comes to the symbols, we are going to start from the distinctive shape symbols. They look like these. We have simply triangle, bubble, and we have output, and this is input. Input A and output X. Please notice that we are going to label inputs of the logic gates by the first letters of the alphabet, and outputs we are going to label by the last letters of the alphabet. So if you are going to see letters like A, B, C, D, E, F, it means that we talk about the inputs. Anytime you are going to see letters like X, Y, Z, we talk about outputs. So this is one way to draw the inverter, and we can also draw inverter like this. And this is my input A, and this is my output X. Someone can ask, they look different, but what basically is the difference? You're supposed to just look at the input. We have no bubble. So anytime we have no bubble, it means that this is active high input. And anytime we have bubble, but this time we have bubble at the output, it means this is active low output. So we have active high input and active low output. In this case, we have active low input and active high output. What it really means, you are going to learn in the next lessons. So we discussed distinctive shape symbols. You can draw also inverter in another different way, which is called rectangular outline symbol, which look like this. We have inverter and we have triangle, where this triangle represent polarity indicator. This is called polarity indicator. So we have input A, and this is my output X. Also, you can draw the same inverter as like this. This is input A, and this is output X. Again, this triangle is nothing else, just the polarity indicator. So this is the same thing like the bubble for distinctive shape symbols. So this is my input, this is my output, this is my input, this is my output. In order to understand how inverter works, we're supposed to remember the truth table of the inverter. TT stands for the truth table. Because inverter has just one input, we can apply two combinations to the input. Okay, my input is A and my output is X. We have two combinations, 0 and 1. Inverter is going to give me the complement of the input. So if I have 0 at the input, output is going to be 1. If I'm going to have 1 at the input, output is going to be 0. So if you are going to look at the diagram, this is my inverter, this is the most popular symbol, and when input is 1, output is going to be 0. Or if input is 0, output is going to be 1. This is basically what this truth table means. Next, we're supposed to discuss the logic expression. Logic expression is the basically algebraic expression which represents this component. Okay, so if you have, for example, inverter, and you apply A to the input, output is going to be equal A naught. Okay, so this is the expression which is going to represent the inverter. if you are going to see expression B naught, without long thinking, you're supposed to draw or just think about the inverter which has input B, okay, and output is going to be equal B naught. Let's say if at another time you are going to see, for example, expression D naught, automatically you're supposed to think about inverter which has input D, and X is going to be equal D naught. Whatever we just cover has to be in your head from this moment on. So in order to be professional, in order to be good student with digital logic, you're supposed to remember all 7 gates which we are going to cover. So this is the first one, and let's do some problems with this.